Hello, welcome to Math Kangaroo Lesson 5. So today we'll talk about mathematical logic. We'll first be talking about magical squares, then logic reasoning. First, let's talk about magic squares. Magic squares are used sometimes during math competitions. They're square grids with a special arrangement in them. Generally, every row, column, and diagonal add up to the same number. For example, in this magic square, numbers 1 through 9 are used, and the numbers add up to 15. Now let's look at this magic square. The way to fill it in is to first look at the middle square. We want it filled in with numbers 1 through 9. Therefore, the middle square must be 5. Then we know that the sum of all numbers is 15. So we can fill in some more numbers. This number here is 3. This number here is 2. Based on this, we can fill in the last two numbers, 6 and 4, giving us our answer. Now let's talk about Venn diagrams. Venn diagrams are a good problem-solving strategy. Separate them into two or more circles. This circle is if A is true. This circle is if B is true. So the stuff that's only inside this circle is where only A is true. Stuff inside this circle is only if B is true. The stuff in the middle is if both A and B are true. Put the cases where neither A or B are true outside. You can also add a third circle, C, for as many circles as you want. Basically, if we put a case inside one of the parts, if it's inside a circle, then that condition is true. Now let's try to find patterns. How many squares are next? We can see that every time we increase by one space, we add one row of squares, just 3 squares. Since the pattern is 1, 4, 7, and 10, the next number should be 13. Now let's practice. How many blocks will be in the next figure? Good job, the answer is 15. This is because our pattern is adding 2, adding 3, adding 4, and so on, meaning next you have to add 5 blocks to get 15. Now let's talk about arithmetic reasoning. Let's do this with the problem because it's a bit hard to explain otherwise. Andrea, Branimir, Celestin, and Doris, but not necessarily in this order, are ranked 1 to 4 in the fencing tournament. If you add Andrea's, Branimir's, and Doris's rank, your total is 6. You obtain the same number if you add Branimir's and Celestin's rank. Who won the tournament? Branimir did better than Andrea? First, we know that A plus B plus D equals 6. Either I'm abbreviating Andrea with A, Branimir with B, Celestin with C, and Doris with D. I do that because it's easier to write instead of writing everything the whole time. It's quicker this way. And if the letters are all different, you can do this. Know that the total is 10 because 1 plus 2 plus 3 plus 4 plus 10. A plus B plus C plus D equals 10. Therefore, subtracting the first equation from the second equation reveals that C is 4. Though Celestin placed 4th in this tournament. Know that Branimir and Celestin equals 6, so B plus C equals 6. So B equals 2. Since Branimir did better than Andrea equals 3. Therefore, the winner of the tournament is Doris. E. Now you practice. 8 cards that are numbered 1 to 8 are inside 2 boxes, A and B, so that the sum of the cards in both boxes is identical. There are exactly 3 cards in box A. Then which of the following statements are definitely true? The correct answer is actually D. So we know that the 8 cards number 1 through 8 are inside the box. And that the sum of 3 of them equal. So, and the sum of the numbers in A and the sum of the numbers in B are equal. So therefore, let's calculate this total sum. Total sum is 1 plus 2 plus 3 all the way plus 8, which equals, so it equals 36. When we divide that by 2, we get that the sum is 18. So let's try to make 18. We can have 8, 7, and 3. We can have 8, 7, 3. Also stuff like 8, 6, 4, so on. However, notice that the least number possible is a 3. Because if there were 2 inside, then it's impossible to get the numbers to sum to 18. Because the 2 greatest numbers are 8 and 7. Sum of these is 17, which is less than 18. Therefore, the answer is D. Practice again. 6-legged, 7-legged, and 8-legged octopuses serve Neptune, the king of the sea. 7-legged ones always lie, and 6-legged and 8-legged ones always speak the truth. One day, 4 octopuses meet. The blue one says, "You have 28 legs altogether." The green one says, "You have 27 legs altogether." The yellow one says, "You have 26 legs altogether." And the red one says, "You have 25 legs altogether." What color is the octopus that speaks the truth? I'll give you a few minutes to think about this, and if you have an answer, please type in the chat. The correct answer is actually C. I'll explain this one. So, we know that there's 4 different answers. Therefore, only one of them can be correct. So there are at least 7 liars, at least 3 liars. 7 times 3 equals 21. We know that the remaining one should be telling the truth. So he either has 6 or 8 legs. You see that if there's 8 legs, then the sum is 29, which is greater than the biggest one, 28. Therefore, he can't have 8 legs. So one telling the truth has 6 legs. So the sum is 21 plus 6 equals 17. 27. Therefore, the green one is telling the truth. Next, let's talk about general reasoning. In front of me, there are 3 boxes, one white, one red, and one green. In one box, there's a chocolate bar, and another an apple. One box is empty. The chocolate bar is in either the white or red box. An apple is in neither the white nor the green box. Which box is a chocolate bar? We have 3 boxes, white, red, and green. A is the correct answer. I guess you got this one. Let's move on. Practice. Lena has already laid 2 shapes on a square playing board. Which of the 5 shapes can she add to the board so none of the remaining shapes have space to fit? So if you have an answer, please type in chat. I'll give you a few minutes to think about this. The correct answer is actually D. So let's start eliminating them. First, there's only one way to place C, which is down here. Therefore, we have to take one square, at least one square from down here. We can't do that with B, because actually we can. But it's still obvious that C is not the correct answer, because if we place C down here, then all of the other ones can fit. Now let's look at A. We must have at least one square from the bottom row, so A can have a few possibilities. Here, 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 or here. Notice that for all these possibilities, there is a way to fit something else. For example, the T box. T box fits in here, because the only possible thing for A is this one. However, that's also not right, because E can fit in here. Therefore, A is wrong. Now let's look at B. Since we have to place at least one square in the bottom row, B must be like that. But notice that many other shapes can fit, so B is not the correct answer. Now we're down to D and E. Let's look at E first. Since there has to be one square on the bottom row, and at least one square over here, E is impossible. E doesn't work, because E cannot put one square on both the bottom row and up here. Therefore, E doesn't work. Therefore, the answer is D. However, let's check this first. The way you should do it is by putting D over here. Note that there are no ways to place any other shapes, so D is the correct answer. The co-row is a cube in which the letter V, Z, C, L, A, and I appear on faces 1, 2, 3, 4, 5, and 6 respectively. What is the fraction of symmetric letters, either horizontal or vertical, on the cube? So V, Z, C, L, A, and I. We can immediately see that L is not going to be symmetric, and C isn't either. However, C, V, A, and I are. Therefore, we have 4 out of 6, which means the chance is 2/3 is our answer. The following shape is made out of small cubes. Since the answer is already here, it's not really practice anymore, so what fraction of cubes are not visible in the picture shown before? First, let's calculate the number of cubes there are. There are 2 times 2 times 4 cubes equals 16. Now let's try to see how many cubes are visible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 13 are visible. So therefore, the answer is 3/16. Because it's 3 invisible cubes out of 16 total cubes. Now let's try to solve some problems. Pia is folding a yardstick consisting of 10 equally long pieces. Which of the following figures can she not make? Correct answer is actually A. Let's try to solve this by eliminating choices. First, B is eliminated. Now let's eliminate C now, so this might be a little bit tricky. But we can do it like that. The C is also eliminated. Now let's look at D. We can do it like that. Notice that we can eliminate all of them except for A, which is non-eliminatable, because no matter how I try, I cannot make it. So the answer is A. Might have been a little bit hard to see, but all of these actually can be eliminated. Daniela fills a 3x3 table using the digits 1 to 9 so that each field contains only one digit. It has already placed the digits 1, 2, 3, and 4 in the table as shown in the diagram. Two numbers count as adjacent in the fields, which they still have one common sign. When she's finished filling the table, she realized the sum of the numbers adjacent to 5 is 9. How big are the sum of the numbers adjacent to 6? Note that the smallest number of things something can touch right now is 3. And the number 9 is pretty small, so therefore 5 has to be here. This is because no matter where we put it, the number has to touch at least one of the numbers 6 through 9. Therefore, we place 5 here, 6 over here, which is the only method possible. Therefore, since 6 is in the middle, it touches 5, 7, 8, and 9. And so therefore, sum is 29, E. Next problem. Robert makes 5 statements, one of which is wrong. His son Basil has 5 sisters. My daughter Anne has 2 brothers. My daughter Anne has 2 sisters. My son Basil has 2 brothers. I have 5 children. Which statement is wrong? So I'll give you a little bit of time to think about this, and if you think you have the answer, please type in. So we have an answer of D, which is correct. So, summary, we learned about mathematical logic today. First learned about magic squares. Then we learned about logic reasoning. We learned about Venn diagrams, how to find graphic patterns, arithmetic reasoning, general reasoning, simple probability.